Thank you.
Excellent.
Thank you.
Well, I feel like I'm obligated to tell the joke that our CEO always tells, the CEO Anthony Goldblum, says we may be able to solve AI, but we cannot solve AV. So I feel like I had to share that on his behalf. Well, once again, welcome to the beginning of our second day of the M5 conference. And as Maria very kindly made an introduction, we're going to try to address this question of, will artificial intelligence take your job? I am Addison Howard. I am the competitions lead here over at Kaggle, who helped host the competition. And on the next slide here, you'll see my colleague as well, who is Walter Reed. He was a data scientist who helped us. Valentina, so you can move along to the next slide. And so Walter was one of our competition data scientists, helped prepare this problem as well. Oh, looks like we still need, there we go. And then we can go ahead and move over to the third slide. Let's answer the big question that we asked at the top of the top of this presentation here. Next slide, please. Maybe is the answer. Will machine learning take your job? Maybe. As was addressed, not only is there a lot of automation happening here with machine learning and artificial intelligence, but machines cannot do things that require a novel approach or things they haven't seen many times before. So machine learning can only go as far as they've seen data and seen patterns and learned and been trained and been implemented into the world. In fact, a very common example that machine learning is still trying to get its head around is folding laundry. It's something that is still seems like a very simple task, but if you put a piece of crumpled laundry on the floor, it's a lot difficult for a machine to understand how to fold it, because it's not the exact same thing it's seen every single time. Now, we've started off, and your 14-year-old son, that's great, yo. We started off with machine learning, if you think back, with recognizing handwritten letters, things used by the Postal Service as it comes to sorting mail and envelopes. We've gone all the way from assessing credit risk, and then now we're getting to more in-depth medical items like can we detect eye diagnoses? And so if you think about it, the future of work, as mentioned, we're creating new jobs because now we're allowing doctors and other practitioners to spend more time doing the creative elements of their job. If you can allow a doctor to spend less time viewing x-rays and saying, is there a tumor in here, and more time actually performing research or providing the bedside manner or whatever it may be, then we can actually say, no, the future of work will allow for jobs to, we can automate the parts of our jobs that may be more rote or more repetitive, and then therefore take the rest of that work and use it for good, use it for better, use it to be more productive. Let's go ahead and head over to the next slide, please. So what is Kaggle? Maybe you've heard of this yesterday many times talking about the competition. Maybe you participated yourself. Kaggle is the world's largest machine learning community. We're a part of Google. We have been for the last 4.5 years. And we started with machine learning competitions. In fact, our CEO, who I mentioned earlier, started this a little over 10 years ago by trying to predict Eurovision. I think many of you are familiar with Eurovision, given the presence we have here in Europe today. But if you're not, this is a singing competition where every country submits one representative to try to compete. And what our CEO recognized was that there were some opportunities here for some prediction. There actually is some signal in the data as it relates to the Eurovision competition. And so we got the data set into a nice package, presented it to the world, and the world will be able to make predictions and say, here's how I think the participants will end up finishing. What he realized then was that we might have something here. At this point, machine learning hadn't reached a stage where there was a lot of brick and mortar institutions that were teaching and implementing machine learning in their classrooms. And a number of individuals, professionals who were trying to learn and practice machine learning didn't have an outlet to do so. Or they might be spending 80% of their time cleaning the data, and now we're giving them an opportunity to actually practice their machine learning skills and techniques. And not only that, but now we're pairing some of the world's smartest and brightest minds in machine learning with hosts who have problems that want to be solved. Thus, Kaggle competitions were born. And we now have over 8 million members, 24 million uploaded solutions throughout competitions. We have over 16,000 competitions that have been launched, including close to 400 that are our featured competitions on our main page. And finally, over 120,000 open data sets. And I say open data sets because as we started out with competitions being sort of the flagship product, if you will, we realized that Kaggle was becoming not just a competitions platform, but truly the home of data science, where individuals and practitioners were coming to Kaggle to learn and to practice their skills. And then that then went from simply making a model and seeing how accurate it was to finding external data to be able to use in your projects. To then we opened up Kaggle notebooks, providing individuals all across the world, regardless of their hardware stack they have at home, the opportunity to use machine learning in a cloud notebook environment, even if they don't have that space on their own. We also have Kaggle Learn, opportunity for people to take online courseware for things like learning about deep neural networks and simulations and the like. And so Kaggle has become a big user base, and it's allowed us to expand and to present the M5 competition to this new audience. Where formerly, as many of you here are part of the conference, are known for being forecasters, and this is now bringing forecasters and machine learning together, an element that may not have been married before. Let's head over to these next two slides, please. I want to go over a handful of items that Kaggle has helped solve in the past. A few examples here, Valentina, so you wouldn't mind moving along to the next slide. Thank you there. So what kind of problems has Kaggle helped solve? Really anything that we can fit into the format of insert data, export, output, we can make into a competition. And so a few examples, things like categorizing e-commerce products by image. Think about how many retailers, Walmart included, may be looking for, somebody is searching for a product on the website, and maybe they don't know the exact search terms of what they're looking for. Can we use machine learning to improve the search algorithm that returns back the images as opposed to just text-based product listings, but returns the images based off of the search terms that a customer is looking for? The image I have here on the screen as an example is spotting distracted drivers using computer vision. What if we were able to reduce the number of accidents on the road that were caused by distracted drivers if we can understand when a driver is distracted and make make change there? Many of you may have cars that actually have indications of when your eyes are on the road or somewhere else, and that's the help of machine learning. In manufacturing, this is very common. Can we cut the automobile manufacturing time spent on the test bench? That's a very efficient, nuanced process that every single speck of sand involved in the manufacturing process can be an element of efficiency or inefficiency. Can machine learning actually improve that? I know we've run competitions before where our hosts have said, I've worked here for 20 years and the Kaggle community knows my factory better than I do in the first week. And that's what machine learning can bring. Or identifying the boundaries of a car in an image. This is a competition that is on Kaggle. You can see it for Carvana, which is a new spin on the car sales market. And they were finding, hey, can we take an image of a car and actually cut around it in the image so we can place that car in any spot all over the world for our marketing purposes, which is really exciting. Valentina, so you can head over to the next slide, please. And so it's a couple more here I wanted to highlight, and then we can jump into some of the technical elements of Kaggle. Think about what types of cancer treatment will be most effective. This is really getting into some of the depths of will machine learning, how can we use that in medicine? I know yesterday there's one of the talks was on how individuals may be making their own predictions, but then what if you actually, instead of using your own prediction, you created a model based off of your predictions? Think about this similarly. What if we then turn to machine learning as an element of improving cancer treatments for patients? that can sometimes remove the human element of it and allow patients to have a data-driven approach to hopefully improve their cancer diagnoses. In the environment, this is a very common one. On Kaggle, we run multiple competitions with these groups, but can we identify endangered right whales using aerial photographs? If you're at all familiar with this space, biologists will go on expeditions on boats and have cameras on top of the boats, and they simply hope they can temporarily grasp one whale's dorsal fin coming out of the water, and they try to say, "Oh, that's Spiros the whale," and they're hoping to identify, okay, Spiros is in this location. I know where he is, so I can move forward from there. And then they can try to identify migration patterns. Well, if we can use machine learning to identify those, that helps biologists get back in the lab. And then finally, here at the bottom, grading written essays. Grading written essays is a really common, or is a very unique perspective. If you think about it, we've heard about elements of bias in education, whether that be racial or gender bias or another type of discrimination, unintentional discrimination. Well, if a machine learning algorithm can remove the human element and actually provide grades automatically, that can help teachers and professors end up more accurately and fairly grading students' essays. These are just a couple different problems that we've used with Kaggle. Move on to the next slide here, Valentinos. So we asked the question, how do Kaggle competitions work? We're known primarily for supervised machine learning competitions, which means that the answer is already known. Now, there's a little bit of a trick here because when we're doing forecasting, the answers are not known. But generally what happens is we provide users with a set of information. In this case, it's a very simple problem. Will a customer default on a loan? Very customary, traditional, pretty easy, if you will, problem in somewhat of a forecasting space. In the future, will they default? Let's say they give you just age, income, and then we tell you, did they default or not? You will then use this model or use this data in the blue here on the left, the training data, and they'll train a model to understand how will this impact or predict in the future, will they default on a loan? And then we give you the same information, same types of information, age and income. We ask, did they default? That's the test data. And that test data is then scored against what we have behind the scenes, the actual answer key, using the evaluation metric, and that gives you a score on the leaderboard. On the next slide here, sort of what does Kaggle then bring to the table? Machine learning competitions aren't new. Obviously, the M competitions have been happening for decades. Well, the first thing is we bring what we call the power of the gaggle. I kind of joke that a lot of the success that we've been able to experience at Kaggle is we're just riding on the coattails of the success of Kagglers and machine learners. But what we're doing, we're presenting the problem to the world, and we're having practitioners from all different expertise come and participate in the same in this problem. What's so unique, I find, for a lot of these competitions is you often have people from different walks of life teaming up that may have different backgrounds. So, for example, you may have somebody say, "Hey, I am a great machine learning expert, but I do not know anything about retail. Do you want to join up and be a part of a team for the M5 competition?" And somebody says, "Hey, I'm a great statistician. I'm great at traditional forecasting methods. I don't really know machine learning, but I'm trying to explore it. Perhaps we can combine." And those types of that collaboration creates great outputs and great efforts for and really more accurate models. In addition, Kaggle, as I mentioned before, we've done this for years. We've done competitions for so long that we have a lot of understanding of where the gotchas are, where the edge cases are, trying to prevent opportunities for people to cheat or to take advantage of a problem statement, as well as the platform itself providing opportunities for participants to discuss, share notebooks, share code, to have their submissions scored automatically, as opposed to perhaps making a submission, waiting a few months and coming back and getting a score. All that is automatically built in. And the next slide here, I want to show you what a leaderboard looks like. This is the leaderboard for the competition. I'll show this again a little bit later on for those of you who haven't had the chance to see it yet. But there's a real-time scoring in leaderboards. And this, I think, is what makes the competitions truly unique. And turning what may otherwise be a research problem into a competition, how that can bring an advantage to actually pushing the state of the art a little bit further. So throughout the competition, there's a public and a private leaderboard, as was explained a little bit yesterday as well. And individuals can make a submission and get a score back on a subset of the true answer key. And that allows them to iterate and to hone and move on. But really what it does is it creates a signal to everybody else entering. Here's what's possible. Here's what can be achieved in a competition. So if we go to the next slide, I want to give you a sort of a collaborative example that we have. Kind of silly, so bear with me here. But maybe you've seen this problem before in the classroom or as a child, and you might ask yourself, how many triangles are in this photo? Now, normally, if we were in person, I'd look to the crowd and get you to shout out some answers. But typically what happens is maybe the first person says, oh, I see 12. I see 12 triangles. And so now everyone knows there's at least 12 in this photo. And then maybe someone says, well, I see 15. And the first person who said, how did they see 15? I only saw 12. And you can keep going back and forth, and there's a collaborative element of raising the bar of understanding. There's a little bit more there that you can accomplish. There's a little bit extra. So if you go to the next slide, let's show you what this looks like in practice. I have a competition was on mapping dark matter. And Martin O'Leary, who is a PhD student in glaciology from Cambridge, made a first submission and lowered the error. So in this case, lower is better. Lowered the error on day one of what happened here. Let's go to the next slide here and show you this great quote from the White House. I'm sorry, the next slide, please. The world's brightest physicists have been working for decades on solving one of the great unifying problems of our universe, and in less than a week, Martin O'Leary, a PhD student in glaciology, outperformed state-of-the-art algorithms. But it doesn't end there. So if we go to the next slide here, Valentino, so I'm going to have you kind of click through a couple of these. It's sort of an animation-based slide. So go ahead and click through them. Excellent. So you see here that then, while Martin started out in the orange, then this team in yellow ended up taking one step further. And then this team in green took another step. And then Martin leapfrogged them again. And the green team leapfrogged them again. And what essentially a competition does, as we've seen on Kaggle, is it creates sort of an understanding of where does the industry state-of-the-art currently live? We can see where it plateaus based on existing technology right now. And that brings us to sort of a limit based on the data set of what machine learning can achieve. And the competitions are very powerful to finding exactly, it catalyzes bringing people to that state of the art, as well as finding that limit. And so let's go to the next slide here. I want to sort of wrap up here with the final half dozen slides or so. Let's look at actually what happened in M5, and let's celebrate a couple of the pretty key statistics here. I know opening yesterday, Maria highlighted some of the great stats that we have, but I want to bring you a little bit more detail on exactly what our competition had. So as you know, we had two separate competitions. One was predicting accuracy, one was predicting uncertainty, or rather where accuracy was the target and uncertainty was the target. 88,000 submissions, over 88,000 submissions for the accuracy competition with 306,000 unique page views. 306,000 unique page views. The M competitions have such a global audience and reach. It's such an incredible number. 41,000 people signed up to participate in the competition, with over 7,000 making a submission. And 101 countries were participated in this event. I actually have a graph here and a few slides to show you as well what that looks like. I have both scores here showed for you, but I want to highlight here the bottom 3 bullet points on both of these, and I'll show you what this looks like in a bit more detail in just a few more slides as well, is the public notebooks, discussion topics, and messages. Public notebooks means that there's a number of individuals who are saying, I'm willing to share my code with the world so that way other people can learn from it, even if it means I may not get the best score. And so I'm going to put a pin in that thought as we'll get to that a little bit later to show you what that means. 415 teams beat the highest existing benchmark for accuracy, which is 7.4%. And then on the uncertainty competition, 22% of teams beat the highest statistical benchmark, which is absolutely incredible. Let's go over these next 2 slides, please, Valentinos. This next one here is just a bit of a broader perspective on the leaderboard for the accuracy competition. You can see on the left, those are all the teams, their final ranking, their final scores. If you do see that second most column, it shows you sort of the shakeup, which is I know was discussed a little bit yesterday, where they were on the public leaderboard relative to where they are on the private leaderboard, which may have been indication that there was some attempts at, or some unintentional attempts at overfitting, or what have you. But those individuals ended up at the top. And then I can show you here on the right-hand side, what is the top leaderboard score over time. What's always so exciting to me is seeing in competitions that typically the best score in the competition is submitted within hours of the competition ending. So it really does come down to the wire. So this next slide here, please, Valentinos. Thank you very much. And so this is the uncertainty competition, the exact same view as well. Wanted to show you that leaderboard score and the final competition leaderboard. What I also think is very interesting is you can see about 2/3 of the way through the competition, there's that stair step down, which is often an indication that maybe somebody had a breakthrough, somebody had a unique thought that ended up truly bringing that accuracy to another level, or in this case, the uncertainty to another level. Next slide, please. What's really great here is I'll leave this here. The MPOC competitions is drawing such a global community. It truly is unbelievable. As I mentioned before, 101 unique countries for the accuracy competition, dozens and dozens more for the uncertainty competition. And this is just a brief heat map of exactly where everybody is coming from when they were participating. And these next two slides that I want to show you, I use the axiom, a rising tide lifts all boats. And that relates to both discussion and to code, as I'll show you here. These are a screenshot. I know it's maybe a little bit small to read here, but you can also go to the competition pages after this and see them as well. These are individuals who are asking questions in the forums. And you might say, it's a competition. Why would anybody ever share their secret sauce? Why would anybody ever share their proprietary knowledge about what's happening here? Well, what we find is that just like the how many triangles problem, by asking a question and sharing a little bit of what you have, you may end up actually raising the floor for everybody. And so asking some questions about, hey, here's papers, as you see here a little bit down the road, I think it's R. Dizzle said, here's a bunch of papers from the 4th competition. Or the very last one in that column says, here's beating the M4's winner score using this library of NBeats, this technology of NBeats. And you see a lot of questions around, what about other past time series competitions? What can we learn here? It's such a collaborative environment that lets people share and discuss and really raise the bar, or rather raise the floor and lower the bar for entry, so that way anybody can actually approach the problem on day one. So you see, these are all some of the top elements here. You can see all these upvotes that are being provided. On Kaggle, we have a ranking system where people can achieve a status of expert, master, grandmaster. We've been fortunate to find that rankings of grandmaster hold a credential in the machine learning space that is often on par with some of the top brick and mortar institution degrees. And in some of these situations, you can see the gold circle surrounding their name. That means they're a grandmaster. It's a red circle, they're a master. And those are simply recognition by the Kaggle community, people saying, this is a voice that I want to listen to. This is somebody who has led the discussion well, or somebody who shares really great notebooks, or somebody who shares great data sets, somebody who wins competitions. These are all credentials that gives people authority, if you will, in the Kaggle community. And a lot of it comes through that collaboration. And so the next slide, Valentinos, not only does a rising tide lift all boats in discussion, but it does in code as well. So again, you might ask yourself the question, why would anybody ever share their code in a competition? The majority of people come to Kaggle to learn. I think anybody is appreciative of any prize that they win, but as you saw in these leaderboards, there was such a shakeup that if you finished the competition in 600th place, and all of a sudden you're in first place, you may not have expected it. And so a lot of people will come to contribute, to learn, to test their knowledge, to improve their everyday machine learning skills. And you can see here, people are sharing notebooks. Now, most of the time, those notebooks they're sharing aren't going to be the exact best performance of their model, but normally it might be an introduction, or it might be, hey, let me get you to this accuracy level to try to see if you can improve from there. So you can see here, this is a heads or tails. This is a Kaggle username who put this back to predict the future interactive M5 EDA. So he used an exploratory data analysis and just provided some very high level insights to the data that maybe somebody say, oh, I've heard about the M competitions, but I'm kind of intimidated to join. I don't know if I'm really good enough. I don't really want to, I don't have the hardware to download the data and explore it. Heads or Tails has already done it for you on Kaggle. You can explore the graphs and have a better understanding of maybe where to begin. Maybe just visually you see an insight that other people haven't, and you can then explore it a little bit more. It's a great opportunity for people to not only become grandmasters, obviously on Kaggle, but also become great voices in the machine learning community by writing notebooks and telling great stories through their code. Next slide here, please, Antinos. And then finally, this last slide I want to leave for you before I have a chance to open up to questions is more just a visual of it. Again, these are all things that are being submitted by the Kaggle community for anybody to open, to maybe copy and paste, to explore, to say, I want to take this and make it a little bit better. And these are all great visuals of the data being used in the M5 competition that may help other people get a leg up or have a better understanding of what is happening. So not only do we have these great visuals on the left, you'll see on the right-hand side here, the top right one, M5 Align and Submit. This is one of the highest ranking notebooks. This is submitted by Matthias, who came in second place. Congratulations, Matthias. I hope you're listening here this morning or this evening, where you're located. You can take the full notebook and submit it and get a second place score. So that we actually see end to end the notebook and the code that generates that. Or below it, see that one of our Kaggle grandmasters named came in 13th place. Now, we only awarded the top 5 winners in each competition, but you find dozens and dozens of Kagglers writing a full-length write-up of their techniques, their tricks. What did they try? What did they not try? How much of their model, perhaps, if they were to take away a very complex piece and keep it very simple, how would that change the accuracy and the performance of the model? And so what you can find is that the Walmart team or the M5 team, or the M conference team, or anybody across all the competitions can go back to these competitions and say, well, yes, maybe these top 5 teams won. I'm going to read the write-up of team number 6 or team number 24. Maybe they have a unique element that if I take a little bit of theirs and a little bit of theirs and a little bit of theirs, I can create an even more accurate model based on this collaborative element in the machine learning Kaggle community, and end up building something that is even better than what any individual team can do on their own. That is all that I had for us today. I believe we have just a few more minutes at the end. I want to open up for questions if there are any, as well as I know that my colleague Chris is going to be presenting after me, and want to make sure we don't have hopefully any of those technical issues for him as well. But I'll pause there and see what questions I can answer for those for those who've been listening in. And thank you,
Thank
Valentina,
you, Addison. Thank you very much. Very, very interesting. Let's see if we have any questions on the Q&A section.
I don't see any open questions at the time.
Yeah, there are no questions. Again, thank you very much, Addison.